Hello and welcome to test number 7, looking at some math skills in chemistry. So we're going to start off with a question for everybody, and we're looking at a chemical reaction that starts with 85 grams of reactants. 0.28 grams of gas is given off. Calculate the percentage of the original mass that was lost as gas. Okay. Now, if we look, this is quite straightforward because that's already in grams and that's already in grams. So it is a straightforward 0.28 divided by 85 times by 100 because we are calculating the percentage mass and it's just 0.329. So that's a straightforward one. Just checking our units are the same, straightforward divide and into a calculation. Okay, question 2 then. This one is one of those that everyone thinks is really hard, but actually it's just the terminology. A scientist has a sample of copper 2 carbonate hydroxide, and that's the chemical formula there, and you look at that and you think, I don't know what that is, and that sort of throws people, but really all you're looking at is, you've got copper there, Cu, and you've got your periodic table, so you can look to see what it is if you're not sure, and there's 2 of them. I've got OH in brackets, and a little 2 by the side, so that means there's 2 of everything in the brackets. So I've got 2 oxygens and 2 hydrogens. I've got 1 carbon there, and then I've got 3 hydrogens there. That's all that means. It's just all the chemicals, the way they're joined together, make this copper carbonate hydroxide. It says, calculate the MR. That means work out the relative formula mass of the formula. And all that means is unpack how many chemicals are there, the elements and how many there are of each one, and then actually use this information, and whenever you see this information where they give you the atomic mass of each chemical, you've basically just got to add them all up. So all I do to start with is I always unpack the equation first so that I know I've got exactly the right amount of chemicals. So first of all, like I said, I've got 2 carbons there, so I've just put 2 coppers there, so I've just put 2 coppers there. Now, if you look, I've got 2 oxygens here, but I've also got 3 here. So I've got 5 altogether, 5 oxygens. Hydrogen, I've got 2, and carbon, I've got 1. Okay, so have I checked off everything in there? Yeah, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. Right, I've got all my chemicals. Now all I do is I change the symbols for the numbers. So copper is 63.5 and I've got 2 of them. Oxygen is 16 and I've got 5 of them. Hydrogen is 1 and I've got 2 of them. And carbon is 12 and I've got 1 of them. So I work that out and add it all up and it comes to 221. Straightforward calculation. The other way you can do this, tackle this question is if you just want to write out all the chemicals that are in the formula, you just write them out. So I've got copper, add oxygen, add hydrogen, but I've got 2 of them, add oxygen, add hydrogen, add carbon, add oxygen, add oxygen, add oxygen. And then just substitute them all for the numbers and add them up that way. Either way, it doesn't matter. So the answer is 221, and that's a straightforward adding up the masses. That's all it means. Relative formula mass just means add up all the masses. Now, the reason I've put this triangle here is because you usually need to do this to put that number into the moles calculation, because that goes over here. The relative formula mass usually goes into a calculation there, just so that you've got that for the future. Okay, so question 3. At room temperature and pressure, 1 mole of any gas occupies a volume of 24 decimeters cubed. What volume would be occupied by 0.025 moles of gas at the room temperature and pressure? So, and then it says give your answer in centimetres cubed. So the first thing I'm doing is, okay, right, I'm looking at how many moles of gas I've got. I've got that times the 24 volume. So that's my answer, 0.6 decimetres cubed. However, they want my answer in centimetres. So in order to get it into centimetres, I need to multiply it by 1,000, and the answer is 600 centimetres cubed. Okay, so this question then is a bigger question, looking at some data and actually plotting a graph right from scratch. A student recorded the change in concentration of a product over time and during a chemical reaction. Her results are shown in the table below. Okay, so time, so obviously that's the one that I controlled, so that's my independent variable. The one that I measured, concentration, was at the bottom there. You can see that's the one that's been changed. Plot the results in the table on the graph below. Draw a line of best fit. Now, most times on the graph, you're going to have to draw a line of best fit, and you need to have a look to see whether it's going to be a straight line or a curve. But the first thing I've got to do is I've actually got to plot the graph, and I've got to see what goes where. So if I can just get this all onto one, let's just pull that up a little bit so you can see the whole thing. There you go, that's better. Okay, so I've got my table of data and I've got my graph. First of all, remember, the independent variable, the one that you controlled, always goes on the x-axis. So that always goes at the bottom. Now I've got to get from 0 all the way up to 60. So I always check first of all before I write any numbers. So 0, 10, 20, yep, that will fit. I can get 60 on there. You don't want to be doing 10, 20, 30, 40, 50, 60 and only using half the graph paper. You want to use as much as you possibly can. The concentration then has got to go from 0 all the way up to 4.3. Okay, so if I just go a little bit above 4.3, I'm probably looking at about 5. So if I look on here, can I get 5 on here? 1, 2, 3, 4, 5. Yes, I can. So I plot my numbers. I make sure I write my axes, the labels with the units, and now I'm ready. Now that alone gets me 2 marks. My third mark will come from actually plotting my results. And I always use a ruler and I say, right, okay, so at 10, it was 1.7. At 10, it's 1.7. And I go across, put a dot, and then make sure I draw a nice, neat cross. Don't just leave it as dots, because as soon as you draw your line of best fit, the dots will disappear and you'll lose your mark for plotting. At 20, it's 2.9. and so on, and that's what I do. I plot all my points first of all. Now, quite obviously, this is not going to be a straight line, because if you look, it curves up. And the thing that most students make a mistake here is they just go, oh, you know, should I sort of, oh, I'll just join this, oh, and I'll join that up, and end up with a really wiggly line. That is not a line of best fit. A line of best fit is just going to be one smooth curve, whether it hits all the points or not. You want to look at where the pattern is, the best that you can. Now, the way I suggest you do this is I always put my hand on the paper like this, and with a pencil. I'm using a pen today so that you can see the line. And I just pretend where the curve is going to go. I'm like, okay, that curve is going to go sort of about there. It's going to go about there. It's going to go about there. And I've got my hand in the correct position, ready to draw the curve. And then literally I just put my pen down and I go for it and just draw one smooth curve. Don't worry if you make a mistake, because as long as it's one smooth curve and you've gone through most of the points, that'll be fine. If you start going, oh no, I've done that wrong, and going, oh yeah, and oh that, you'll lose your marks. One smooth curve. Now, question 5 says, using the graph above, estimate the time at which the concentration of the product is 3.3 moles per decimetre cubed. So all I've done here is gone to 3.3. I've drawn a line across until it hits my curve, and then I've drawn a line down so that I can now take the time from there, and I can see that the answer is between 25 and 26. Okay, you should just go for either one, 25 or 26. They usually give it you one way either way, but it's very tight. You've got to read your graph properly. Okay, thank you very much, and I look forward to seeing you on test number 8.